Hi everyone. Today's lesson is going to be irrational equations. This is an example of irrational equation, and let me explain why. So first of all, we are dealing with the roots, not just anything considering the roots, but the unknown is inside of the root. This is the important part. So whenever we want to find out what the value x has to be, and it is inside of the root, we call this type of the equation irrational equation. Now, considering the irrational equation, there are a couple of things we need to keep in mind every time we see this equation, this type of the equation, when we want to solve it. Before we go into the solving, we need to make certain that everything is set up properly and that we actually can solve it as it is. And there are going to be cases, and I'm going to show you today, when even if we are able to solve it and find the solution might not be the solution that exists for this equation. Now, reason being is the definition of the root itself. The root of a positive number, meaning everything inside of the root, always has to be greater or equal to 0, specific 0 as a case on its own. And the solution, or the value of the root, is also a positive number. So we have the root, and it is equal to a, and has to be equal to positive number. So there are a couple of things we need to make sure that work properly, or are written properly, or given properly, defined properly, and then we have to execute considering that. Meaning, whenever we talk about irrational equations, similar to rational equations, where x is in the denominator, we will have to look at the conditions or proofing. Now, since last year, I'm not going to show you the proofs themselves. They're simple enough and explanatory on their own. What I'm going to concentrate is the conditions, because I think in the long run, conditions are something that we're going to work with more, and we're going to have to apply them more frequently than just proof of equality. So let's go through the conditions. So let's give a couple of examples of if the equation is even set up right. So conditions. So basically, when you look at the irrational equation, what you want to make sure is if it's even worth to solve it or go into the solving part. Let me show you a couple of examples considering that. So let's start with example A. So in the example A, I'm going to give you following equation. Square root of x minus 9 minus square root of 3 minus x is equal to 5. So when you look at this, first of all, there are a couple of irrational parts, basically two roots we are given in this case. Now, what are we going to do? We're going to check what's going on with the part that is inside of the both roots. Now, important thing is that both these conditions, depending on the root, have to be true or have to be met, meaning that we are working with AND. We are working with AND or intersection in the end. So if I just look at the condition part, so x minus 9 and 3 minus x, we have to make sure that x minus 9 is greater or equal to 0, and, this is important part, and 3 minus x is also greater or equal to 0. Now let's solve individually these two equations. So first of all, I would add 9 to both of these sides. I would get x is greater or equal to 9. And this persists, and minus 3 is going to be greater or equal to, minus x is going to be equal to minus 3 because I've subtracted everything with 3. And last step is I want to see what's going on with the x, so I'm going to multiply or divide with minus 1, meaning, do not forget, that the inequality is going to turn. So x is going to be less or equal to 3. Now look at the end. Now I'm going to show you what's going on the number line. You can always you don't have to use it, but I would encourage you just for the sake of it, so you know what you're dealing with. So number line with 3 and 9 pointed out on it. And what's going on with the x's? X's have to be greater or equal to 9. So this is the one part. And in the same time have to be less or equal to 3. And is intersection. And means I'm looking at the number that is both greater or equal to 9 and less or equal to 3. There is no such a number. So in this here case, x is element of empty set, the condition, basically. So at the start, without even solving, without finding the solution, I didn't even show you how we solve these things. Well, what we're going to do is say that if we do not have anything worth for the condition, there is no number that we can possibly get, well, this irrational equation doesn't have a solution. So you just write it down and you're done with this task. So this is the starting point of everything. Let's look at the B example, another situation that might appear. And let's go with something simpler. I went into something a little more complicated. Let's go back a bit. So in the B example, we're gonna have square root of 6x minus 3, and it is equal to minus 11. This should be simple enough. Now, of course, there is condition inside of the root that 6x minus 3 has to be greater or equal to 0. Let's leave it for now. I'm gonna look at a greater picture of all of this. And the greater picture says the following. The root itself, the definition of the second root is that the second root has to be greater or equal to 0. It is a positive real number, and especially 0 as a case of its own. Now, this has to be equal to the right side, meaning that the left side that is greater or equal to 0, a number that is greater or equal to 0, has to be equal to a negative number. It has to be less than 0. So this doesn't make sense. This irrational equation can appear. It is possible in a sense. It can be given. It can be written down. It is a sentence, but this sentence is not true. This doesn't make sense. So this irrational equation doesn't have a real solution. So in this here case, we're all again going to write down x is element of empty set, because this doesn't make sense. So what I wanted to show in these couple of examples is look at a little bit of a greater picture, determine, so we can look at the conditions. Of course, this condition is irrelevant for the specific situation of B example, but then look at the greater picture. Well, the whole root is a positive number and it has to be equal to something negative. Well, this doesn't make sense. This doesn't work. We stop here. We don't solve it. And the last example I want to give you, considering just the conditions and the greater picture, and if it's worth solving this equation, is example C. Now, let's look at this. Let's look at a square root of 5x plus square root of 6 minus 2x is equal to 0. Now, okay, let's look at the conditions, the basic conditions. The basic conditions are what's going on inside of the root. So in first case, x has to be greater or equal to 0, because 5x has to be greater or equal to 0, but 5 doesn't matter. It cannot be equal to 0, so the only other guy in this whole picture is x. And 6 minus 2x also has to be greater or equal to 0. Okay, now let's leave it like this. I'm not gonna go into the condition of the root itself and what's going on with the x's. I'm gonna go again into a greater picture. This is the goal of this here little exercise, so to say. So if I look at the greater picture, let's look at the left side. So this is a positive number or 0, so greater or equal to 0. Another root is also greater or equal to 0 because we're working with the second root. Well, if we add them up, we have to get 0. So this leaves us with a specific situation. When are we going to add up two positive numbers or zeros so that we end up with a 0? Well, both of them have to be equal to 0. This means that square root of 5x has to be 0 and square root of 6 minus 2x has to be 0. And this is the logical step. Now, without much of the solving or dealing with stuff as it is, like 5x has to be equal to 0 because root of the 0 is equal to 0. So this means that x is 0 in this case. Well, the same thing applies for the second root here. So 6 minus 2x has also be equal to 0, which leaves us with a number that x has to be 3, because 6 minus 2 times 3 is 6 minus 6, which is square root of 0, and it is equal to 0. Now, in mathematics, it's not possible that in the same time, for one number, it exists another solution or number. Basically, one number cannot be two values at the same time. It is unique, so to say, as a number. So if we work with and, well, we got two of them. This doesn't make sense. X is element of empty set. This irrational equation doesn't have a solution. So this is the first part. This is the conditioning, and further down the line, the tasks ahead, we will have to do conditions all the time. We will have to think about what's going to happen. Now, what I'm going to tell you, just for the sake of this lesson, is these were the examples where we have to look at the bigger picture. What I'm going to give you now, further on, is solid. So everything works, everything is fine in the bigger picture of the equation, but what we're going to still do is the conditions, the small conditions, what's going inside of the root and what has to be the x in order for it to work. And we're going to see a couple of different types of irrational equations, different situations, and we're going to see whether we are always going to get a solution. Maybe one solution, maybe no solutions, maybe multiple solutions. So let's see what's going to happen. Let's start with the task 1. First type of equation. Simple enough. I'm going to use the equation that was already written as a representation of irrational equations. So let's solve square root of 3x plus 5 equals to 7. First step, without starting the solution part, let's determine the condition. So condition in this here case is going to be that 3x plus 5, basically everything that is inside of the root, has to be greater or equal to 0. Let's start with that. Now I'm going to subtract everything with 5. 3x is greater or equal to minus 5. Divide everything with 3, and x has to be greater or equal to minus 5 over 3. This is the condition. So if we get for the solution number that is equal or greater than minus 5 over 3, everything is fine, and the solution is good. Now let me go back into the equation and let's get into the solving part of this equation. So first step is we want to get rid of the root. And before I go into this, the getting rid of the root, let me explain you what's going on in the future with all these tasks that I'm going to show you. Whenever we work with irrational equation, whenever we work with root, no matter if you have one or multiple roots, what you want to do is have just one root solo, alone on one side, everything else goes on the other side. So when you square everything like this, at least this root that is alone is going to be solved, so to say, and we're going to get rid of it. Now, one thing I have to also mention, in this here case, I'm going to write this down without applying the root itself, the square, sorry, is that we're going to get square root of 3x plus 5, everything squared, is equal to 7 squared. Now, the definition of the root says that if you have square root of x squared, this is equal to x. This is the definition of the root. There is also another definition that's going to pop up later on, which is conclusion or result of the definition, is that if you have square root of x squared, where x squared is inside, the square of a number is inside of the root, that leaves us with the absolute value of the x, because we have to make sure that the root is positive value. Look at this. We have to make sure that this sticks. So if the square is outside of the root, or we squared the root, in that case, we can say that root and square are going to cancel each other out, and what's inside is left we have as the next step. So 3x plus 5 is on the left side, right side is going to be 49. What we got is a linear equation, something that we thoroughly did last year, so let's solve it till the end. Everything minus 5, 3x is equal to 44 divided by 3, and x is equal to 44 over 3. Well, 44 over 3 is a positive number, and it is because of that 100% greater or equal to minus 5 over 3. So this is the solution of the given equation. Here we go. This is the method. I will have to transform the given irrational equation so that I have, or the equation has one root on alone on one side, everything else on the other side. Then we square it, we apply the square, we get to the linear part, or maybe some other part that we learn, and get to the solution as it is. Let's look at the task 2. Let's continue on. Another situation. So in task 2, square root of x minus 6, then plus 8 equals to 5. Okay, this is nothing major, nothing special. Do not forget, let's figure out the condition first. So condition in this here case is that x minus 6 has to be greater or equal to 0, which leaves us that if I add 6 to both sides, x has to be greater than 6 or equal to 6. If we get this, fine. If we don't, well, then we don't have the solution. So first step of solving actually this equation is going to be to subtract everything with 8. So if we do that, we're going to get square root of x minus 6 equals to minus 3. Now let me show you this example and let's continue on, even though I hope at least some of you understand that this might have an issue. Look at the B example. Now, what will happen if you forget about looking at the bigger picture? This is the one example where you have to look at it. What happens if you forget about the bigger picture? Is okay, I have now on one side alone the root, everything else is on the other side. Let's just square. Okay, so this means that x minus 6 is going to be minus 3 squared, which leaves us with 9. Let's add 6 to the both sides. X is equal to 15. Checks for the condition. It's perfectly fine. We actually got like you call it, we got a beautiful number, simple number, no major things. But where things stop working is in between these here two rows. Because you squared something that you should not have squared. Why? Bigger picture. Left side is greater or equal to 0. At the same time, minus 3 is a negative number. This doesn't make sense for the real set. This doesn't make sense for the definition of the root in real set. This is where we stop. This is not correct. X is element of empty set. We don't have a solution in this here case. So watch out for that. Watch out for that. Okay, let's go back to normal stuff. Let's continue on with the task 3. Task 3. The task 3 is going to be 7 times square root of 9 minus 2x minus 4 and then equals 10. This is now the equation. Okay, this is now the main thing. Let's start with the condition. I'm gonna go with the condition here. So we have just one root, so this means we have just one condition at the moment. So 9 minus 2x has to be greater or equal to 0. Subtract everything with 9. Minus 2x is greater or equal to minus 9. Let's divide everything with minus 2, meaning we are dividing with a negative number. X is going to be less or equal to 9 over 2. Okay, now we got that. We got the condition. Let's go back to solving. So if I want to solve this, I want to get, if I can, first situation where I separate the root on one side with everything else on the other side. So first step would be add 4 to both sides. 7 times square root of 9 minus 2x is equal to 14. And I would encourage you to do, but if you don't, it's okay. But what I would encourage you to do is divide with 7. Now, this is important. So you actually have a lone root, but if you don't, it's still okay. But make sure if you square now, that you don't forget to square 7 times, so 7 squared times square root of 9 minus 2x squared. So you have two squares multiplied with one another, or in a multiplication, is equal to 14 squared. I'm not going to do that. I want to have, as I said, I want to use one method, and that is to have alone, if I can, the root on one side. So this is one dividing with 7. So square root of 9 minus 2x is equal to 2. Everything works. This is all fine. Positive equal to 0. The whole root is positive equal to 0, and it is equal to positive number. It's okay. Now we can square. Let's go on. So this means that 9 minus 2x is equal to 4. Of course, now we're going to subtract with 9. Minus 2x is equal to minus 5. And x is, when we divide everything with minus 2, x is equal to 5 over 2. Let's check it out if this is the actual solution. I think it sticks because 5 over 2 is less than 9 over 2. Good. And we are done. So these are 3 examples so far. 2 of them worked. For 2 of them we got a solution. Everything was okay. Now, let's continue on. Let's continue on with expanding this the irrational equation with 2 roots. So let's go with task 4. Task 4 is going to be square root of 4x plus 1 minus square root of 2x minus 3 equals to 0. Now, let's look at the bigger picture before we go into the condition. Well, we have a positive number or 0 minus another positive number or 0, and it is equal to 0. It should be possible. This should be possible. If here was a plus, then we would have a situation similar or equal to the C example at the beginning, where 2 positive or equal to 0 have to be 0, meaning that both of them at the same time have to be equal to 0, and that wasn't possible. Now, here with a minus, everything is okay. So, let's do the condition. Now, unlike with the tasks before, in this here case, we're going to have 2 conditions, but I'm going to show you that in the end, one of them or combination of them is the condition itself, because usually you have one big condition and it then has to be applied to the solution, or such solution has to be within the condition. So let's start with 4x plus 1. So 4x plus 1 has to be greater or equal to 0. And at the same time, 2x minus 3 has to be greater or equal to 0. Let me make sure why it's and one more time. Both of these values inside of the root have to meet the definition of the root, meaning that both of them at the same time have to be greater or equal to 0. This is why it's and. Okay, when we solve these conditions separately, x has to be greater or equal to minus 1 over 4. This is one of the conditions. And the other is that x is greater or equal to 3 over 2. So now we have both of these. Now, of course, in the end, when you get the solution, you can check, does it work for this? Okay, it works for this. Does it work for this? Works for this. If it works for both, it is the solution. If it fails for one of them, well, then it's done. But what does the and mean? And in mathematics means intersection. So if I use number line to check what's going on, minus 1 over 4 is on the left, 3 over 2 is to the right, x is greater or equal to minus 1 over 4, meaning it's right from minus 1 over 4, including, and 3 over 2, also including. The condition itself is the interval from 3 over 2 to infinity. This is the condition part. This is where the solution has to be, and then everything is okay. Now, you can write it down. You can keep it like this. What I would encourage you to do, to have at least, is the number line. Let me write down the condition itself. So condition is that x has to be greater or equal to 3 over 2 plus infinity. There we go. This is basically the solution of an equation, or two inequations, or system of inequations with one unknown. Okay, let's go back to the equation. Now we are ready to solve it. As I said, I want to separate roots. I want to have roots alone on one side, everything else on the other side, no matter if we have two of them. So, since we have two of them, they have a minus between them. Well, let's use the negative one and have it on the other side. So I would have to add to both sides square root of 2x minus 3. So this gives us that square root of 4x plus 1 is equal to square root of 2x minus 3. Okay, now we have roots on their own sides. Let's square it. Let's go with the square. So next step is that this is going to be 4x plus 1 equals to 2x minus 3. Oh, we got the linear equation. Let's solve this. Minus 2x for the both sides, and let's use minus 1. So this is going to be 2x equals minus 4. Let's divide it with 2, and x is equal to minus 2. Now, we are not done. We got the solution, but we are not yet certain if it's solution for the starting equation. Let's check it out. Minus 2, oh, it doesn't fit the condition. This isn't the solution. It's not. So x is element of empty set because of this. See? You can be given equation without solution. Everything fits until the very end. Task 5. Let's look at if instead of addition or subtraction, what do we have? Multiplication between the roots. So look at this here situation. Square root of x plus 2 times square root of x minus 2 is equal to x. Let's look at that. Oh. Now, first of all, before we go into the solution, let's determine the condition. Let's start with the simpler ones and the obvious ones. We have to check what's going on with the roots. So inside of the root, we have x plus 2, and it has to be greater than 0. And also, x minus 2 has to be greater or equal to 0. Let's start with that, meaning that x has to be greater or equal to minus 2, and x has to be greater or equal to 2. Sorry about that. Greater or equal to 2. If I use the number line to see what's going on, let's see them too. So minus 2 and 2. Greater, different graters, including the brackets. So at the moment, it looks like this is the condition. So everything greater than 2 is going to be the solution. This is not the end, though. We didn't check one more thing. Roots are in the unknowns are in the roots, but the unknown is also outside of the root. And this is what you have to look as a bigger picture. Whole left side is either 0, because any of these two can be 0. You're not certain though. Or greater than 0, because greater number than 0 multiplied by another great number that's greater or equal to 0, well, everything has to be greater or equal to 0. So whole this thing has to be greater or equal to 0. Meaning that the x, because of this, also has to be greater or equal to 0. So we have another condition, hidden condition, another end, x is greater or equal to 0. Meaning I have to add the 0 in all of this. Everything that is greater than that, okay, now I'll use something like this, including it. Oh, it still sticks that the x has to be greater or equal to 2 for it to be a solution. So everything still sticks, but this is the extra stuff now. This is the combination of the bigger picture and the conditions of what's going on inside of the root. Now, how do we solve it? Now, first things first, we learned something about the product of roots. So if you have two roots, as long as both of them are greater than 0, x and y, which are inside, which we did determine or made sure they are with this condition, we can put them all in one root, if it's multiplication or division. Let's apply it to this here task. So we made sure that both of these values inside of the root are positive, so we can put it all in one root. Let's go, is equal to x. Now, why did we do it? We did it so that we have root equal to something. It can be unknown, I don't care. Now, one more thing I can do before I go into the squaring. Well, this is difference of squares, if I'm correct. So let's apply the formula for difference of squares. X squared minus 4 is equal to x. Now, let's square everything, which leads us to x squared minus 4 equals to x squared. Oh. If I subtract everything with x squared, what is going to happen is minus 4 is equal to 0. Oh. This isn't possible. Again, x is element of empty set. Nothing works. Just to make it clear, everything we did so far was correct, fine. This is the method we do. It's okay. But look how much the definition of the root can set us up for something more, or even give us the idea that we're doing something wrong, even though, for example, more than a dozen times we got that, more than a couple of times we got that we don't have a solution in the end. This is the thing with roots. I'm starting with things like this because I want to show you that it's not as simple as it seems to be, specifically considering your textbook where everything works properly fine and everything is good. So watch out for that. Okay. I'm going to leave it with this as an ending for this video. I'm going to continue on with 2 more examples in the follow-up video. I don't want to stretch. Make sure to go through this thoroughly. I'm going to give you 2 more examples. And see you guys in the next video. Take a break a little bit and continue on afterwards. See you guys in the next video.